Okay, we're live. Hello, everyone. This is Nikolai, Postgres TV. I'm alone today in terms of hosting. Ilya is a little bit late. Maybe he will join a little bit later. And this is Open Talk series where we select talks from Postgres conferences and redo them to present to a wider audience. And today we have an interesting talk from interesting guest, Ibrar Ahmed. Hello, Ibrar. Thank you for coming.
Hello.
Thank you for coming. We will talk about artificial intelligence plus Postgres today, right? So it's like combination of two fields of engineering and like databases and data science or artificial intelligence, machine learning. And I'm looking forward to this talk. Before we start, as usual, I ask everyone please subscribe, because a lot of people don't do that, and I think if you're interested in Postgres, you should find our guests and our content interesting, so please subscribe. And as usual, I ask, please share the link in your social networks, working groups, Slack, Telegram, Discord, what you have at work. And just let's start. Please share the screen and we will continue.
Yep. Thank you. So I think you can see my screen right now.
1 second. No, 1 second. Yeah, I can see it. Mm-hmm.
Yep. Thank you and welcome everybody. So today's topic is a quite interesting topic about the PostgreSQL and the artificial intelligence. So PostgreSQL is the main database we are talking about, but the whole idea is how we incorporate artificial intelligence or machine learning into a database. And specifically in the PostgreSQL we are talking about, because it's a PostgreSQL talk. So we'll discuss that, how we incorporate artificial intelligence in PostgreSQL and how PostgreSQL can be part of the artificial intelligence. That's a both way. It's not a single way that artificial intelligence can go into database, but database can participate in artificial intelligence. So we will discuss both the aspect of that. So my name is Ibrar Ahmed. So welcome everybody. I'm the principal engineer at Percona. So I have it's a little bit of my bio that I have been in a software industry since 1998 and working on PostgreSQL since 2006. And I authored multiple books on PostgreSQL and also work with the Google projects. So other than that, why artificial intelligence? Because I have been experience of PostgreSQL. Why artificial intelligence? Because I almost finishing my PhD in artificial intelligence. So in the last stage of my PhD, so I have to give my final defense of the artificial intelligence. That's one academic area and one area. So I want to combine the both expertise, my professional and my education career. So artificial intelligence, what I will explain in the PostgreSQL and artificial intelligence. So initially at the start of this talk, I will introduce what is artificial intelligence. So we will closely give a look about what is intelligence, what is the part of artificial intelligence. Then we will describe the integration aspect of PostgreSQL and artificial intelligence. So third, I will show you one example demonstration about using AI in PostgreSQL. So the artificial intelligence. So what is artificial intelligence? So if I go to some bookish thing of the artificial intelligence, what is artificial intelligence? The machine that mimic the cognitive function that human associate with the human mind, such as learning and problem solving. What is that? When you think about that as a child, when child is start learning, actually he start reading and then start solving the problem. And this is the process of the years and years. This how much data it has, it's just reading and learning and then start solving the problem. So it's similar with the computer. When you start feeding the data in computer and in some aspect of learning, the computer start learning that And at that stage, when it starts solving the problems, so it's 100% mimic the human mind. Like human is also reading, learning, and then it's capable of solving the problem. So it's similar with the computer. So some definition that artificial intelligence is no match for the natural stupidity. It's Albert Einstein. A machine with a strong AI is able to think and act like a human. It is able to learn from experience. So it's again Albert Einstein. I think the development of full artificial intelligence could spell the end of the human race. The one who become the leader in this sphere will be the ruler of the world. So that's some the big people are saying about that. So artificial intelligence is a broad term. Whenever say that, whenever talking about the artificial intelligence, to have learned that it is everybody is talking about the artificial intelligence, but it has some kind of types of artificial intelligence. So one is the ANI, artificial narrow intelligence. So artificial narrow intelligence has a narrow range ability to perform a specific task. Like if you train your computer to perform a single task and continuously performing that single task and continuously performing single task, then it is called artificial narrow intelligence. And somehow in scientific way, it is already been achieved. Somehow it is achieved. So second one is the AGI, artificial general intelligence. Artificial general intelligence can perform different tasks that human can do. So you know that human mind can do a lot of things. So if we mimic the 100% capability of human to perform a task in a computer, then it is AGI. That means it can do whatever a human can do. So it's a general intelligence, artificial general intelligence. So right now, the has not been achieved this yet. We are struggling to achieve that. We mimic that this is a computer and this is a human mind. So it's equivalent. So, but we are not at that stage right now. But somehow we have achieved artificial narrow intelligence. So there is another type of that. It is artificial super intelligence. So artificial super intelligence is ahead of general intelligence. That artificial super intelligence is more capable of a human, learning from past experience and from a new data to do a variety of tasks. It's surprising that it surprised the people that how is it possible that a computer can perform a better task than human mind, because human mind have a capacity that it cannot remember the huge data from the past. So if we are able to achieve the AGI, artificial general intelligence, that our computer can do a task what a human can, but if you feed more data to that and computer can remember the data, then it can able to perform artificial super intelligence tasks. So it's possible, but it's difficult. We have to learn about that. We have to do some more research to get at that point that a computer can start much better than the human. So you can say this subfield that previously I said that's a type of artificial intelligence where we want to achieve that. The subfield of artificial intelligence, we are talking about the machine learning. It's a subfield of artificial intelligence. Then native computing, and then the natural language processing and computer vision. These are the different fields of subfields of artificial intelligence. So when you are doing some machine learning, it's also artificial intelligence. When you're doing a deep learning, it's also. So today we will much more focus about the machine learning and neural networks first, because if you go to the every detail of every subfield of that, it's a bigger field to discuss about. So I will touch a machine learning and deep learning and neural network specifically in that. So type of machine learning. Machine learning has three types. Like I told you that artificial intelligence has a different types of fields, and machine learning is one field of artificial intelligence, and the machine learning has a three types. So machine learning is that when you feed in data into the computer and give him some kind of information, and it start processing that information, and then when its model is created, then you can give him data and get the information. So first time is a supervised learning. What is supervised learning? Supervised learning is when you feed in the data, like you feed in the data that already have the answer for it. So you will provide that data to the computer, and provided that if I can give you the example of that if it's a class, and there is a class, and sorry, if you can give you this is the apple and this is the orange. Let's give the more simple example other than that. One apple and one orange, and do give the characteristics of apple, and you said that this is the apple, and give the characteristics of orange and said this is the orange. So you feed in the data into the computer, and computer will learn that these characteristics are of orange and these characteristics of apple. And when sometime you provide the data of some characteristics, it will predict this is the apple or this is the orange. So you provided the data and you also provided some answer, and your model is trained on that. Then whenever you provided the data which doesn't have an answer for that, so it will predict that what is it. So where it is used? It is used in the classification and regression. Like classification, if I provided the data of apple and orange, a model is created, then I will give him a bundle of a packet of apple and oranges. It will do the classification. It will say these are the oranges and these are the apples. So it will separate them very clearly because it's already learned the characteristics of apple and orange. So it's similar. If you give that to apple and orange to a child start looking at that. This is this shape of the apple and orange and the color and everything. And you say your children that this apple and this is orange. That's mean it is a supervised learning that you are supervising the child that this is the orange and this is the characteristics of orange and this is the characteristics of apple. And at that time, when you provide an apple or orange to a children, and immediately he said that I need the apple, and he will pick the accurate apple because his mind has learned from your supervision that characteristics of apple and orange. So that's called a classification. So it does classification work. In some cases, you don't provide supervision, like a child. If your child is start learning himself, that he said that when he go to the bed, he knows that daily he going to the bed and start sleeping on that. He got that mind. This is the bed, and this is the table, and this is the chair. He's learning. If you are not telling the children what is it, but it start learning. So if you don't provide the data, so it is the answer of the data. You provide only the characteristics, not the actual answer. What is the characteristics of what? So it is called unsupervised learning. So where it is used? It is used in the clustering. It is used in the association. Like if you provide apple and orange and only know the characteristics, you don't know what is the apple and what is the orange. But if you provide that apple and orange to the computer, it will just segregate that these are the separate entity and these are the separate entity. It doesn't know which is the apple and which is the orange, but it will separate down that both have the separate categories, characteristics. So that's called clustering. And what is the association? Association is that if you start feeding, like if you are a grocery store and you start feeding the data, which person is buy what item. So you continue to provide data. So at the end, when you ask the computer, if somebody is buying bread, what he is buying other than that? So you get that one person is buying bread, he's always buying an egg, he's always buying a milk. So you have that kind of a data. So ultimately, it will give you the result that just place the bread, eggs, and milk in a one shelf, because you got the information from your computer that person is buying bread, he's also buying eggs. So you have that information now. That means you created an association between bread, eggs, and milk. So it's really easy. Just put that in one side of the store. So it will give the ease and it will increase your sales. So you got the information from the computer. And that's called unsupervised learning, because you have not said that this answer of that, but you just give the data, and computer learn about that, who is buying and what is the association between the item. Third one is the reinforcement learning. In the reinforcement learning, you don't have anything. If you put your computer into the robotic, it's used in robotics. I put in your robot in a center of the room and let him learn. Let him learn. Like if he go 5 steps ahead and he feels there is a wall, so it will adopt that. If I from center I go to the front, there is a wall. So it will learn that. If he go right side 5 steps and 7 steps and see there is a window, and if he go left, there is a door, and behind there is a wall. So when he goes do multiple trips, he will start learning where is the window, where is the door, where is the wall. That's important, because now your robot has learned the architecture of your room. So when you say robot, just go to the outside of the room, he will directly go to the door. He will not go to the window, because he already learned that where is the window, where is the door, where is the wall. So that's called a reinforcement learning, where it's a hit and trial. He go there and feel that this, what is this? So that's called a reinforcement learning. So process of machine learning, I told you what is this types of machine learning. So now we go to the process. What is the process? The process is you have a data. You provide the data to your computer. And before that, you clean your data, prepare and manipulate data. That means if you have some kind of outliers and something like that, just do some pre-processing of data and get your clean data. And then you put that into your model, into your computer, and it will start training. Like if it's a supervised learning, you have the characteristics of apple and orange, and you said that it is apple, it is orange. So you put that into model. When your model is trained, so then you give the surprise data to your model. You provide only the characteristics, not the answer. So it will predict what is that. So if your prediction is 90% or 99% is correct, then your model is good. It depends what is good for you. It's 80% maybe. Sometimes 80% good is good for you. 90% good is good for you. It's up to you how much accurate. If it's not accurate, improve. Again, put the data, get more data, and just provide the data to train your model. When your model is ready, then you can provide the surprise data to your model, and your model will do the rest of your work. So, and mostly when you have a full data set, you train your data mostly on 70% of your data, and you keep your 30% data for the test data. So your model is trained on the 70%, and 30% will ensure your model is correct or not correct. So now the deep learning. So, and the main characteristics of machine learning that we are providing in machine learning, we are providing the characteristics. Because I told you, if it's a supervised learning, it's unsupervised learning, if it's a reinforcement learning, we are providing the characteristic. Like if I give the example of orange and apple, that orange has orange color, like it's a soft, apple is a hard, it's a different color. So we are providing the characteristics, and even in the bread or something like that, we also providing the characteristics. And reinforcement learning, we are also providing that what is window, what is door, what is that. But if you don't have the characteristics, then here comes the deep learning and neural networks. We have to extract the characteristics from that ourselves. So nobody is providing that. Computer has to extract that information. So it has the neurons. Neurons has in our own head actually. So in the body and everything. So we have a neurons. So human brain has the neurons. So we have also have the neurons here. So here you can see that the input layer, where you provide the input, and you have the some hidden layers in that, and you have the output layer where your data is. So you provided that data, hidden layer will do that. Like I can give you the example on the next slide of neural. If this neural network is more deep, it has the more, you can say, layers, then it is called a deep learning. So neural network is the one thing where we don't have we have a 4 or 5 hidden layers, but if we have a more layers and more neurons, then it calls a deep learning. So I can give you the example so you can understand much better. So here we have a deep learning. You see that we have a lot of layers here and some input and some output. So you can see that I have a big picture where I have to recognize the picture from a big picture. So you can see that from one layer, from here, one layer, we extract the eyebrows, look like the eyebrow. So we are extracting the feature one by one. We have not provided anything to the computer. We just provided this whole big picture. So it start extracting the eyebrows, something like that. And next, it start recognizing the face feature and then the face. And finally, it recognize the pictures. So if it's a machine learning, we provide that what is the color of eyebrows, we provide the shape of nose, the color of hair, something like that. But we don't know. We are just providing the picture and ask him to recognize the picture. So the deep learning is extracting the feature from the using the deep learning process, extracting the feature and then recognize, and your output is there. If your output is not correct, we go back to the input layer. There is a lot of mathematical information required, that the differential, the back propagation, so everything will be happening here. But I really don't want to go into the mathematical detail of that. I'm just giving the information how it works, so how we can relate into the database. So next we could go to the database actually. So machine learning versus deep learning, I already told you that we have an input, like we have an input of car. So a human is sitting there, extracting the feature of the input of the car, like it has a 4 wheels, it has a windscreen, it has doors. So human is extracting the feature of that. Then if it's a bike, so if it has 2 tires and steering is different. So human is extracting. And when we do the classification, it will say it is a car or it's a bike. It's a car, it's a bike. So it will automatically recognize because we already provide the feature to the machine learning. But in deep learning, we provided a car and it will start it. The deep learning automatically extract the feature that it has a 4 wheels and something like that. And when you provide a bike to that, it's not a car. If you provide a car, it will say it's a car. But keep in mind that one input is not enough. We have to provide a lot of data to that. Like we provide the every type of car, thousands of car types to the input to deep learning. Then our model is trained. Now, whenever you give them the surprise car, it will automatically detect the car. This is high. So data is really important. How much data you have for your training and testing, your model is well trained on. So I will give you example, which is really interesting. So it will give you some laugh on that. So demonstration. So now we come to the database now. The real problem is here because I have some kind of knowledge of what is a deep learning and the artificial intelligence. So we have integer like 31903 So we have to detect that these number has 0 in it or not. So we can do that mathematically. Definitely we can do that mathematically, perform some mathematical operation, some string searching on that, then we can convert that into string and writing a code. But we solve this problem, a very simple problem, using AI and using database. Because if I give you the bigger problem, which cannot be solved using the mathematically, and then we have to solve, it will be complex. So we pick a small problem where we already know it can be done many ways, but for demonstration, really good that we are detecting that 0 is there or not. So in first example, 31903 is true, and 82392, it's false because it doesn't have a 0 in that. So how we do that? Keep in mind that all the queries I have picked, that is one of my friend, as a Bruce Momjan, he wrote that queries. I just modify and simplify that, but I really want to give him the credit who created that example. So this example actually requires the PL-PAL in PostgreSQL. You need to install that extension. So create extension. If not exists, PL-PAL. So it will install the PL-PAL. So all the queries here, you don't need to look at the slide. You just go to there, is that site. You can find all the queries there. So you can run and you can test it. So I'm not going into the detail of the code, what is written here, because I will explain how it works, not how to write it. Because you can always do, because it's some kind of a PAL knowledge required and something like that. So I'm not going into too much detail. So a tensor is the you can say that like some kind of a vector where we store the information. So we're generating a tensor. So I'm just skipping. Actually, we are training data. We are creating some function for training. We are creating a function for the generating the random number, and it is. So we have a data that you can see that in left side, we have a value. You can see the values and you can see the output. Here you can see the values, the output. We have this training data. It's only a, I selected the 10 values. So you can see that the first value 28762748, we provided that it doesn't have a zero. Don't look at the number yet. This number doesn't have a zero. This number has a zero. This number doesn't have a zero. So we have false, false, false. It is a supervised learning. That means we are providing the information that which one has the zero or not. So we feed in the value and the training output to our model. So when our model is trained, then we will give the random number to our model. Then according to this training, it will predict it has a zero or not. So we provide the numbers, we provide the actual final result of that to our model. And when a model is trained, then we can give him a surprise number to detect it has a zero or not. So we have generated a weights, and then we have some kind of for loop where we are training our data. I'm not going to do too much detail on that. Create mass. So it's just for you to experiment these functions. Functions are available. Just run that function. You can get the output. You can change that. You can manipulate that. And there are a lot of APIs available to do that task. What I have done in this. But there is API is also, you can use the API, you can use this code also. So I'm just skipping. So test 100. So now that's really interesting things happening now here. So now I feed it, the model is trained. I showed you the value that we have a value, we have a result, we have trained our model. Now test our model. So when we provide the 100 was not in the training model. So we provide the 100 and asked our system, so is it have a zero in it or not? Look at this. It said it's a 22% chance it has a zero. Wow. Our model is not trained yet. It says 70%, 77% chance it doesn't have a zero. And 22%. Why this is happening? Because we have provided very less data to train our model. That means our model is not well trained. So we have to provide more data to get at least 99%, 98%, 97% accuracy. Here we have only a 22% accuracy. It has zero, but it says it's a 20% chance, 22% chance that it has a zero. So that shows the data is important. What training data is important. If we give them the millions of numbers to that, then we test that it's a 100%. That is 100 has a zero. But data is very less because it will take a lot of time to generate the model. So then accuracy is very low. We need more data to train our model. So again, we are testing 101. 101 has a zero in it or not? They say it's only a 11% chance that it has a zero. Oh, it's a bad thing. Our model is not trained. So trained it again, trained it again, provide more data. When your model is ready, it's similar like your as a child. If child you are not taking your child outside, he doesn't know to recognize the buildings. If you just show him the one building, he only recognize the one building. If you said this is also a building, maybe he's confused because he has seen a one building in his life. So he's not recognized the what is that. But if the child is going outside quite oftenly, so he can recognize whenever you take him some other city, he will recognize the buildings and everywhere because he already have the knowledge in his mind that he is very aware of the what is the building, what is the house. So he has the knowledge. So similar with the computer, if you don't provide enough data to the computer, it will give you the false result. So that's important. Why we are showing this example? Because we are showing that the data is really important here. That's what it is called a data science. And here comes the database. So I will give you an example why we have a problem. So like you can see there, we have a number, it says 68% chance it has a zero. Oh, that's another problem. So we are testing 1,000, we are second table expression. So we all providing the example how we can get the extraction of data. So here the final results. So we provided these values, and this is the values, the output. You can see the final accuracy is 15% on the different number we have provided, which is not good. So we have to improve. So you are keep providing data, you keep getting data, and if accuracy is correct, then you are okay. So that's called a training and testing. In testing, we are not good, train again. Testing, train again. Testing, train again. And when you are satisfied, then your model is ready. So when your model is ready, so now here comes the database. Why to use the database in AI? Machine learning requires a lot of data. So I show you that why it's called a data science, because it's required data, a lot of data. So most of your, you're thinking about the data, and we are talking about the database. Where is your data? 90% chance is data is your in database. So database is built for the data, and your machine learning or your artificial intelligence require data. So why not machine learning? Apply your machine learning algorithm where your data is. So what people are doing, and even I have seen in universities, in the college, in a professional way, what they are doing, they are exporting their data from database into a text file and apply the algorithm on that file. Why? And what is the side effects of that? When you're exporting, you are taking a lot of time of your database, and it becomes an offline machine learning, something like that. If we have that algorithm, what we have created in previous slide, you can practice that. We have a machine learning algorithm within your database. You can provide the table to your AI or machine learning algorithm to manipulate that. So it will avoid the exportation of your data. You don't need to export the data in your text file, and you can do it continuously machine learning process to your table on your table. So that's important. So now you have a data and you have the algorithm within your database. So that's really easy, that you can just apply, just call a function. It will apply a machine learning algorithm on your data, and you could test your data. Don't need to export. Don't need to export, import, and everything you are doing. Don't do that. Apply that, run it. So you can have an algorithm your agent is doing, that it will do a machine learning algorithm after some time, and you keep updating your model. Like if you are inserting 100 rows, then run your model. Your model is trained. Your model is getting better and better and better. Instead of after 1 month, you just export your data and then train your model. Don't do this. Apply your algorithm within the database and leverage your information from the database. So advantage of doing machine learning in a database, use the previous activity as a training data. Like if you start applying your machine learning algorithm data, just add the machine learning function into your database, and you have 10-year data, previous data is there in your database. Don't export it. apply that the machine learning to train your model. Have seamless access to all your data, right? If your algorithm is within the database, you also already have a database, leverage it. Seamless. Pick your data, apply. Take immediate action on AI result, like commit transaction only if likely not fraudulent. If you think that if you have learned, if you teach your, you have a model that can that already learned which is a fraudulent and which is a non-fraudulent transaction. Your model is trained for that. So commit your transaction, immediately take action. If it's legitimate, commit it. If it's fraudulent, don't commit it. So you can take immediate action on that. So AI can benefit from database transaction, concurrency, backup. So you have this kind of a data in your database. So why you can't use this kind of information to train your model to do the action? So other benefit includes the complex database, full text search, GIS indexing. So you can benefit using it. PostgreSQL can do a GPU-based computation inside the database. So you can also leverage from that. So these are the benefit. So in previous slide, I've given you the one. In this slide, you machine learning is getting the leverage of the data on the PostgreSQL. Machine learning is using the database data. That's one aspect. Database AI is here, database here, and machine learning is getting advantage of database because database has the database. That's the one aspect. The second aspect, it's opposite. Like AI is not taking the advantage of database. Now database can take advantage of AI. It's reverse now. How is it reverse? Like user application, performance adjustment. Like if you have, it's a very crude example that you can do a set database setting. You have a database setting and you can do the TPS or something like that, and it predict what is the database setting is best for the database using the model. You train your model, and database can benefit from that model to resource optimization, optimizing the plans, and this kind of a thing. And malicious activity, right? If you detect within the database there is a malicious activity, the algorithm is running, the model is running, and model is trained, so malicious activity easily can be detected. So resource exhaustion, like if you have a model that you have you have the prediction, like if you have a 10 years of data or a machine is running, your resources is running, so it can predict when your resource will exhaust because you already trained your model. It can predict that when your resource is exhausted. So then now database is taking advantage of machine learning models. So that's totally opposite. One, database is taking machine learning is taking advantage of database. Now database taking the advantage of machine learning or artificial intelligence models. So these both sides. So it's a one kind of an aspect. And one more thing that I was learning in a field, that there is a possibility of some kind of AI columns in a database. It's a new thing. Like you create a table and it has a 3 columns in that only. So why we don't have another column in a database, which is a pseudo column, and it is a machine learning or artificial intelligence based column. So what will be the advantage of? There is some tool, some database who has experiment on that. So what is that? Like if start inserting some data into your 3 column, and the 4th column, which is the prediction column. So it will start predicting, like if you say that you're inserting some kind of financial activity, and it will start predicting that you're going where you're going. So if you query where you don't have any data, like you have a data of till 2021, so you can still query 2023 data. It naturally to table doesn't have that data, but your prediction column can predict your growth will be this by learning from previous data. So you can query your data which doesn't have a data. You query your table which doesn't have a rows in it, but only the predicted columns come, and say, oh, 2023, you can have this kind of a value at that time. At 2025, 2026, anytime you can query that. That's mean normal table, you can only query which has the rows. Otherwise, it will give you the no rows. So, but in a predicted column table, you can have the data anytime. So, it's your model is trained, it will give you the data of predicting predicted column data. So it will show your growth. Yeah, like if we have $100 million this year, $200 million next year, 300 million next year. So we have a 3 rows. So we say next year it will say $4 million. So it will predict. It's not like that we just increasing. Chances are there. It's increasing, decreasing, and you have thousands of rows in that, and you can ask your system just predict what will be the next value. So it will show the row that this is the predicted value. So your model is continuously training. So it will give you the data. So that's it. I think it's a very brief artificial intelligence and database. So how to integrate, how your database can get the leverage from the model, and model can leverage from the database. So, Nicole, I think.
Thank you. Yeah, I'm stopping screen sharing for you. A couple of questions. What do you think the biggest we know there are several attempts to build projects that run various machine learning methods inside Postgres and inside other databases. For example, Apache Madlib or MinesDB, which works with various databases as well. But and I personally also use it from time to time. For example, for some forecasting and some prediction and so on. We at Postgres AI use it, but why do you think this is not a mainstream approach? Like why most people who need machine learning and other things, they don't do it inside databases?
Yeah, it's when I'm learning that it's a new thing actually. There's a problem that machine learning and artificial intelligence are usually people think it's you can say that it's an educational thing right now. The professional way of attacking that, because our database, especially database, are old school thoughts. Like if you want to have that in PostgreSQL, in a MySQL, they have the old school concept that they are not going there. And I have not seen that yet because they are the old school. It's from 90s, they are going there. So adoption of new technology, a little bit slow process in database. I've seen that because this is the one thing. A second thing, people are really worried about that when machine learning algorithms are running, it will ruin their performance.
Performance.
Yeah, performance, because the model is training. When the model is training, it slow down your database sometime. It is.
There are popular frameworks like PyChart, TensorFlow, and others, which have very, very huge popularity. If we go inside database and want to run our to train models and so on inside database, do you think it's possible to use those libraries somehow at some point, or this is a big problem as well itself? Because if we are inside Postgres, can we use those powerful libraries? If we cannot, it's limited capability, right?
Yeah, I'm currently working on that. So on a project, I created an extension. It's a Python extension where I'm using some Panda and some other. Panda is the API is available for AI. I'm using different kind for my PhD project. I use that. I have created an extension for PostgreSQL. It is called PGAI. So it's my personal right now. So PGAI. I have used this library in my extension to perform some my PhD. I'm hoping to make it public, so people can have extension where they can use only the SQL queries to perform this kind of a task, not in a core but in an extension, because extension is easy to get into the database. But if you are going to
unless it's RDS, because on RDS only limited number of extensions, like they or some managed Postgres, they offer only limited number of extensions, right? So this is also limitation for some users.
Yeah, that's a limitation. So I think the extension is a really good idea to have that. Even we can have a pseudo column kind of thing in an extension. So
right. And do you think so? Do you use in that project? Do you use PL Python somehow, or
yes,
or,
I use a PL Python. I use a PL Python, of course, because I can use the PL Perl in that. But Perl, we can't find a good libraries of
course, yes. Not many people use these days PL. Perl.
Yeah, Perl is really actually when you are going to master it, it's some kind of messy. It's difficult. But Python is really easy. Everybody can understand that.
Right.
It's really straightforward.
I was surprised you used Perl in your slides. So I expected PL Python as well. But okay, I mean, interesting topic. I'm definitely interested, and I like the idea that we have, if we have a lot of data, we can use the power of Postgres. Definitely, so many things. Actually, you say like it's considered old school, but startups, according to statistics from Hacker News job postings, startups more and more recently, like the latest report was from June, hntrends.com, and it was more than 16% of job postings, including everything like non-technical as well, like managers and so on. They mention Postgres technology, right? It means that startups don't consider this technology as old school. I'm like, it's interesting. Like, you think still there is some barrier in way of thinking, right? So
actually, when I'm talking about the old school, its usage is not old school. Its implementation is old school. Like in a C level,
I understand.
Whenever you use it, it's an advanced database. Postgres is really advanced database right now. But if you're thinking about the implementation in that, it's a school. So adoption, when you're old school, the adoption of database, a new technology, it's some kind of slow process. It's you have to be like extension, where we have to get that AI into extension. Then somehow the people realize that it's really good extension. Then we can have that in a code or something like that. It's a slow process.
Yeah, makes sense. Okay, thank you so much. Have a good week, and again, thank you for coming. As usual, again, I repeat, please subscribe and leave comments. We will be monitoring the comments section, definitely. Thank you so much. Till next time. Bye-bye.
Yeah.